Assalamu alaikum. Today's teleclass on radioactivity is presented to you by myself Ibrahim Muzah
and myself Sunil Kumar.
So in today's lesson, the first part will be brought to you by myself and the second part will be brought to you by Sunil sir. So before we start today's class, we'll just recall what we have studied in the previous class, since we are doing the same topic on radioactivity. So in the previous class, we did discuss the random nature of radioactive emission. We learned to identify alpha, beta and gamma emissions by recalling their nature, their relative ionizing effects and relative penetrating abilities. We learned about the background radiation and discussed about the detection of alpha, beta and gamma. And also, here we have a summary of what we have studied the previous class as well. So as you can see, alpha particle, beta particle and gamma rays, they are completely different in different aspects. As you can see, alpha particles have a +2 charge and beta particles have a -1 charge and gamma rays does not have any charge. The speed of alpha particle is very slow. As we have discussed, the size of alpha particles are quite big, and beta particles it's moderately fast, and gamma rays it's very fast, which is the speed of light, since it is an electromagnetic radiation. The ionization ability of alpha particles are very high, and beta particles it is very low, it's medium, and gamma rays it's very low. The penetrating power of alpha particles are very low, and the beta particles it is medium, and gamma rays it's very high. When we talk about the ability to stop it, alpha particles can be stopped by a thin sheet of paper, beta particles can be stopped by 3 mm of aluminum sheet, and gamma rays can be stopped by lead block. Now we will focus on the objectives of today's lesson. By the end of this lesson, you should be able to describe the motion of alpha, beta and gamma in electric and magnetic fields, state the practical uses of radioactivity, state the meaning of radioactive decay, state the changes to the nucleus when alpha, beta and gamma is emitted, and use equations to represent changes in the composition of nucleus when particles are emitted. So as I've mentioned earlier, alpha and beta it does have a charge, but gamma rays does not have a charge. So this means alpha and beta both can be deflected inside an electric and magnetic field. So in today's lesson, the first part that we are going to focus is what happens to alpha, beta and gamma in an electric field. So let's say, for example, if alpha, beta and gamma, three of these rays, so we'll focus on one ray at a time. Let's say when alpha particle emerges into an electric field, what happens is it does have a positive charge. So which means in an electric field, the alpha particle will be attracted towards the negative plate. So it takes a turn, it travels and then it takes a deflection towards the negative plate. Now when we talk about beta particles, since beta particle has a -1 charge, the beta particle will be attracted towards the positive plate. So it enters into the electric field and then it gets deflected towards the positive plate. But when we talk about the gamma rays, it does not have any charge. Therefore, the gamma rays it moves straight into the electric field. It does not go any sort of deviation. Now something different you might notice, the angle at which both alpha and beta has deflected. It's different. Alpha, due to its heavy size, it takes a long time to get attracted towards the negative plate. But since beta particles are having a very low mass, it gets easily attracted towards the positive plate. Now we will see what happens to alpha, beta and gamma when it passes into magnetic field. unlike the particles falling into an electric field, the way you apply and to identify to which direction it deflects, it's different. Let's say, for example, when we talk about alpha particles, in this diagram, as you can see, we have a magnetic field which is into the paper. So, as you can see, there is into sign, which means there is a magnetic field perpendicular to this surface, and the magnetic field is going into the medium. So, in this case, you have to apply the Fleming's left hand rule. When you apply the Fleming's left hand rule, as you may remember, this is the force, this is the magnetic field, and this is the direction of conventional current, the positive charge. So, which means since this is positive, when alpha particles move into this, we have to apply in such a way that this is positive particles move in this way, and then the magnetic field is into the medium. You apply like this, which means here my first finger is into the medium, which is pointing to the direction of the magnetic field, and then this is the direction of the positive particles, which is the direction of conventional current. So, the particle is going this way and the magnetic field is into the medium and the force is directing upwards. That means this alpha particle will take a deflection upwards. Now, when we talk about beta particles, the case is different. Since beta particles are a beam of fast moving electrons, there is a current flow to the opposite direction. So, which means when we talk about beta particles, let us say this beta particle is coming this way, the current flow will be to this side. So, when we apply the Fleming's left hand rule, you have to apply magnetic field is into the medium and the current is opposite to the electron flow. As I mentioned earlier, beta is a beam of fast moving electrons. For that reason, the current flow will be to the opposite direction. So, we apply like this. So, magnetic field is into the medium and the current is coming this way, Fleming's left hand rule, according to the Fleming's left hand rule. As you can see, magnetic field into the medium and current flow this way. So, the force is directing downwards. So, the beta particle is deflected this way. Now, when we talk about gamma rays, as I have mentioned earlier, gamma rays does not have any charge. For that reason, as I mentioned earlier, it will move straight into the magnetic field. It goes without any deviation, just like in an electric field. Now, when we talk about a situation where the magnetic field is out of the medium, then the way you apply the Fleming's left hand rule, it should be the opposite way. It has to be vice versa. Now, we will be focusing on some uses of radiation. For example, in the first situation, gamma rays can be used in radiotherapy in treating cancer. As you can see, gamma radiation is given to the region where the cancer cells are, and then it is broken down. The DNA of the cancer cells are broken down. So, as you can see, the cancer cells die and then the body replaces it with new cells. Radiation can be also used as tracers. So, as you can see here, it can be injected into our bloodstream. Radioactive substance can be injected into our bloodstream and then it can be used to trace issues inside our body. For example, blood clots and these things can be identified using this tracing process. As you can see, the scanner, it identifies based on the radiation and based on the emission. And you must note that alpha is not used in this one because it cannot penetrate through our skin. In this, they only use gamma and beta particles to do this work. And also, in identifying cracks in pipes which are underground, this radioactive tracing can be used. So, they put in radioactive substance into the pipe and they use a GM tube. Say for example, they use the GM tube to trace regions where the cracks are, and then it can be used in smoke detectors as well. So, as you can see, inside the smoke detectors there is a small current flow and then the alpha source keeps on ionizing this region, and when smoke particles comes inside, the alpha radiation, the ionization does not take place, and the current flow between the positive and negative particles here, it does not take place, and then it triggers the alarm. So this is how a smoke detector works. In this, they make use of an alpha source. Now it can be used as a sterilizer as well. As you can see, gamma radiation is used to clean fruits, and so many things it can be used. Say for example, the hospital utensils. These things also can be used to sterilize. So for that reason, they make use of radiation. To avoid contamination, they make use of the irradiation process, and for this purpose also they make use of radiation. Now I'll be moving into radioactive decay. The previous lesson I did mention something about radioactive decay. So as you can see, the radioactive decay is a spontaneous breakdown of an atom nucleus, resulting in the release of energy and matter from the nucleus. So I have mentioned spontaneous here. A material containing unstable nuclei is considered radioactive. So I have mentioned, as I mentioned earlier, spontaneous. I have highlighted it here. So spontaneous, why is it so important? Why do we mention that it is spontaneous? Because we say it's a spontaneous process because we don't know what time the radiation is going to take place. We don't know what type of radiation it will emit, and we don't know to which direction the radiation will be emitted. For this reason, we say the radioactive decay process is spontaneous. From this point onwards, Sunil sir will take up the explanation.
So already mentioned radioactive decay. Okay, definition of radioactive decay, and also this word spontaneous. Radioactive decay is a spontaneous process. Okay, because of these reasons. Radioactive decay, three types. One is alpha decay, then beta decay, and gamma decay. First we can check when an alpha decay occurs, what happened. Alpha decay. Alpha particle already you study in the previous class about it is same as helium nucleus, and it contains 2 proton and 2 neutron. First we can check alpha decay. When an alpha decay occur, okay, if the nucleus, unstable nucleus contains too many protons, this alpha decay occurs. And when an alpha decay occurs, what are the changes we can check. And this is the parent element. This is an unstable nucleus. Unstable nucleus emit alpha radiation or alpha particle, then form a new nucleus, new atomic nucleus. So already previous class you study about alpha particle. Alpha particle is two, 4, that means 2 protons and 4 minus 2, 2 neutrons contain. Okay, alpha particle contain. Now we can check the parent element. Parent element emit 1 alpha particle. So what will happen to the new elements atomic number and mass number? One example is here. Okay, this is a radium 86-222. So parent element, and this element emit 1 alpha particle. Alpha particle is same as helium nucleus, and it emit 1 alpha particle. So what are the changes in the new element? New element we can check. Look, from this 86, 2 proton gone. That means 86 changes to 84, and also 2 neutron. 2 neutron also lost, and 2 neutron means mass number decreases by 4 and atomic number decreases by 2. That means when an alpha decay occurs for the new element, atomic number decreases by 2 and mass number decreases by 4. Now look, this 2, 4 alpha particle, and this 86 changes to 84 and mass number 222 changes to 218. When we add these two, we have to get this number. So 84 plus 2 will get 86, and 218 plus 4, 222. So once again, when an alpha particle emitted from unstable nucleus for the new element, atomic number decreases by 2 and mass number decreases by 4. Okay. Then next, beta decay. And in the case of beta decay, when a beta decay occurs, if the unstable nucleus contains too many protons and too many neutrons that emit one neutron or proton and to form a new element. Okay. When a beta particle emit, what are the changes in the new element? We can check. Okay. Beta we can write -1, 0. Okay. Beta is same as fast moving electron. Okay. From this, one beta particle is emitted. So what will happen to the atomic number and mass number of this atom? And when a beta particle emit, atomic number of the new element increases by 1 and mass number no change. With one example, we can check that one. Now look, lithium atomic number is 3 and mass number is 8. From this, one electron, that means one beta particle is emitted. Now beta particle is same as electron, -1 and 0. It emitted. Then what about the new element atomic number? We can check. New element atomic number increases by 1 and mass number no change. Understand? Now look, 3 atomic number increases by 1 from 3 to 4 and mass number same. So when we add these two, 4 minus 1, we will get this one, and when we add these two, we will get the mass number. Understand? So when a beta decay occurs, atomic number increases by 1 and mass number no change. Okay. Then next one, gamma decay. When a gamma decay occurs, there is no change of atomic number and mass number because only energy is loses the energy only. There is no change of atomic number and mass number. Now look, one example, plutonium 94 240 emit one gamma particle. So only energy loses, but there is no change of atomic number and mass number. Understand? Now once again, when an alpha particle emit for the new element, atomic number decreases by 2, mass number decreases by 4. And when a beta decay occurs for the new element, atomic number increases by 1 and mass number no change. When a gamma decay occurs, there is no change of atomic number and mass number, only energy loss. We can check with some examples. Okay. Then when an alpha decay occurs, I already mentioned atomic number decreases by 2, mass number decreases by 4. I will explain with one example. Okay. Now look, uranium 92 to 38. And when an alpha decay occurs, alpha decay. Now we can write alpha particle is same as helium nucleus, so 2, 4. And what about the new element's atomic number? We know from 92, atomic number decreases by 2, so it will change to 90, and mass number decreases by 4, so it will change to 234, and this is a new element formed. Now look, here 92 is uranium and 90 is the new element. That element is thorium. Understand? One more example, radium 88 222. Emit one alpha particle, that means alpha 2, 4. the new element atomic number we can check. Now look, 88 changes to 86 because it decreases by 2, and mass number 222 changes to 218. So it's a new element formed. That element is radon. Understand? Then we can check some questions also later. Then in the case of beta decay, two examples I will discuss here. And for example, thorium 90-234. When a beta decay occurs, beta is fast moving electron, we know -1, 0. So what about the new element atomic number? You can think, previously we discussed that one, when a beta decay occurs, atomic number increases by 1 and mass number no change. So atomic number increases by 1. So 90 plus 1, 91. And mass number, there is no change, 234. That is new element protactinium, Pa. Understand? Then one more, iodine 53, 131, emitting 1 beta. So -1, 0. Then what about the new element atomic number? Increases by 1, so it will be 54, and mass number there is no change, so 54, 131, its new element, it's xenon. Understand this much? Then when a gamma decay occurs, there is no change of atomic number and mass number. Now we can discuss some past paper question. Here look, one question. A radioactive decay can be represented by the following incomplete equation. Use the keywords to complete the equation. You can check which particle is emitted. Here protactinium 91-233, and the new element contain atomic number 92 and mass number there is no change. So we can think which particle is emitted. Here atomic number increases by 1, mass number no change. So which particle? Yeah, it's beta particle emitted. Beta, when beta decay occur, atomic number increases by 1 and mass number there is no change. Okay, so here one beta particle is emitted. Here beam of beta particle into the magnetic field. Magnetic field is into the page. So we have to use Fleming's left hand rule to find the answer for this one. So here we know beta particle is fast moving electron, just opposite way the current. So we have to keep our finger like this way. Now magnetic field is into the page. Magnetic field is into the page. And current is opposite of beta particle. And the force direction we have to check. Magnetic field is into the page, current is opposite, and force is downward. So we can think about the answer. In which direction is the beam of beta particle deflected as they enter the magnetic field? Into the page, out of the page, down the page, up the page. So once again, now look, magnetic field is into the page. Magnetic field is into the page, and current is opposite of beta particle direction, and the force is downward. So the answer we got down the page. Understand? Then another question. A nucleus of americium 95-243 emits an alpha particle to form a nucleus of neptunium. Which equation represents this decay? you can try to find the answer. Alpha particle, try to remember the alpha particle symbol, then we will get easily. So, alpha particle symbol is this one and this one. So, we got the answer A or D is the answer. Then we can check which is the correct one. When an alpha decay occurs, atomic number decreases by 2, mass number decreases by 4. So, 95, this is increased. So, this is not the answer. Then we can check here, 95 changes to 93. So, atomic number decreases by 2, mass number decreases by 4 alpha particle. So, we got the answer D. Then another question, sodium 24 decays to magnesium 24 according to the following equation. Sodium changes to magnesium and one particle is emitted. We do not know alpha, beta or gamma. Then what is the emitted particle? We can check here, atomic number increases by 1, mass number there is no change. So, which particle? We know the answer, the particle is beta, is it? So, got the answer B, beta particle. So, these are the things we study today. First, motion of alpha, beta and gamma in the electric field and magnetic field, and use of radioactivity in different field, use of alpha particle, use of beta particle and use of gamma particle, and radioactive decay, 3 types, alpha, beta and gamma. Then changes to the nucleus when an alpha, beta and beta and gamma is emitted, what are the changes? Then use equations to represent changes, and we study different equations.
Thank you for listening, and we will have the physics forum at 1 p.m. So do join us and do send us your questions by then. Once again, thank you very much.
Thank you very much.
Wassalamu alaikum.